Does anyone know the volume of a cylinder? Lights on in 3, 2, 1. What's the equation for volume of a cylinder? For any right prism, the volume is equal to the area of the base times the height. The area of this face is pi r squared times the height, so the volume of a cylinder is pi r squared h. Does that make sense, you guys? Yeah? Okay. What if I told you that the radius was constant, and I wanted to know how fast the volume changes as the height changes, if these are getting bigger. I want to know, with a constant radius, what is the change in volume over the change in height? What's that? Well, yeah, it is, but like look at it as like different units. You know what I'm saying? Like, because one you're talking about an h increasing. Well, what's the unit going to be on change in? If this is in, let's call it inches. The height's in inches, the radius is in inches, and your volume is in cubic inches. What's the units on change in volume over change in height going to be? What's volume? Yeah. What it's going to tell you, that the number is going to be cubic inches per inch. The volume is changing at a rate of some number cubic inches per inch. Does that make sense? It's just like feet per second. Whatever the unit is on top divided by whatever the unit is on the bottom. But if you wanted to ddh both sides, ddh of v, you're going to take the derivative of both sides in terms of h is equal to ddh of pi r squared h. And I tell you this is all constant. What is the derivative of this?
Pi r squared.
Well, let me ask you this. I don't see, did you say x?
No, I said pi r squared.
Okay, we got one answer on the board. What if I ask you the y equals 10x? What's the derivative? What's d dx? This would be dy dx. How did you know it's 10? What did you do? You did the little power rule on your variable, and you just kept that number stuck there. Does that make sense, you guys? So what is ddh of pi r squared h if pi is a constant and r squared is constant? Yeah, does that make sense, you guys? Again, you can take the derivative of something in terms of any other thing. It doesn't always have to be y's and x's, but the same rules apply. Okay? But if this wasn't constant, it's a whole different story. Okay? dv dh, or v prime in terms of h, is going to equal pi r squared. What if I told you that the height was constant? And I wanted to know what the change in volume over change in r was. If h was constant. In this case, we're going to take the derivative in terms of r. I'm going to rewrite it like this. This is all a constant, and this just follows the power rule. So 2 pi h r to the 1.